If a computer just matches exact words, it breaks constantly. Search for puppy, and it won't find a page about dog. Misspell one letter, and the match fails completely. We need something smarter than matching letters. The fix is called an embedding. Every word or sentence gets converted into a list of numbers. Computers are great at comparing numbers, even if they're terrible at comparing meaning directly. Let's build the idea using fruit. Ask two simple questions about each one. How sweet is it? And how big is it? Every fruit becomes just two numbers, one answer per question. Draw two lines, one for size, one for sweetness, and place each fruit as a dot using its two numbers. A watermelon lands big and sweet. A lemon lands small and sour. This is an embedding, a word turned into a point. Apple and grape are both small and sweet, so they land close together on the map. Lemon and watermelon land far apart. Distance between dots is exactly how similar two things are. What if we ask a third question, like how sour is it? Now each fruit needs three numbers instead of two, and our flat map becomes a cube. Same idea, just one more direction to place things in. The exact same trick works for words instead of fruit. Ask different questions this time, like is it royal, and is it alive? Plot king, queen, dog, and cat. King and queen cluster together. Dog and cat cluster together, somewhere else entirely. Now plot a word like umbrella next to king. It doesn't share royal or alive traits with anything nearby, so it lands off on its own, far from every cluster. Unrelated ideas simply don't crowd together. We've used 2 or 3 questions to keep things visual. Real embedding models don't stop there. They use hundreds of questions, each one becoming another dimension, another direction in a space we simply can't draw anymore. Some real numbers. A small popular model called MiniLM uses 384 dimensions. OpenAI's text embedding 3 small uses 1536. Their larger version jumps to 3072. Every one of those numbers is one more question asked about the word. Nobody manually writes these questions. During training, the model learns hundreds of its own subtle features, things far stranger than sweetness or size, and every word gets scored on all of them at once. Before training, a model's map is basically random, synonyms scattered everywhere. After training on huge amounts of text, the map reorganizes itself, pulling similar meanings close together and pushing unrelated ones apart. Because words are now just numbers, you can do math with them. Take the point for king, subtract the point for man, add the point for woman, and you land almost exactly on queen. Embeddings often compare direction instead of raw distance, using the angle between 2 arrows drawn from the center. A small angle means 2 words point in a very similar direction. A wide angle means they barely relate. Here's the payoff. When you type a question into a search bar, that question also becomes a point. The computer isn't matching your exact words anymore. It's just finding the closest dots on the map. In a real system, every document, every paragraph, every product description gets converted into a point and stored, long before you ever type a search. The moment you type something, it gets turned into a point the exact same way, using the exact same model, so it lands in the exact same space as everything already stored. The system simply finds the nearest stored points to your question's point, and pulls those in as the most relevant results. This single idea, closeness on a map, powers modern AI search and question answering. Let's recap. Words become numbers. Numbers become a point in space, using hundreds of learned dimensions. Similar meanings land close together. And search becomes nothing more than finding the nearest points on that map. Now that you know how meaning gets placed on a map, next time we'll compare 3 ways to put that to use: prompting, fine-tuning, and retrieval augmented generation, and exactly when to reach for each one.